we would like to use trigonometric identities to solve equations, trig equations. So the first thing we're going to do is we have an equation. We are given cosecant x minus cotangent x equal to 1 on interval 0 to 2 pi. We are going to separate them. So we're going to write the cosecant x equal to 1, and then on the right side we have 1 plus cotangent x. The next step is to square the left side and right side. Now when we do that, we are simplifying it. Cosecant square x on the left side. On the right side we have a plus b squared. So that's going to give us 1. In other words, 1 squared is 1 plus 2 times cotangent x plus cotangent square x. Now, the next thing is we are going to basically, instead of cosecant square, we're going to write down our identity. So we're going to write down 1 plus cotangent square x. 1 plus cotangent square x. And then on the right side, we just bring everything down. Exactly the same thing. So now, please notice that 1 we have on the left side and also on the right side. So they cancel out. And also cotangent square x cancels with cotangent square x. So, so our next step is to just bring down what we have. 2 cotangent x equals 0. And dividing both by 2 will give us cotangent of x equal to 0. Now, cotangent of which angles are 0? You could tell that that's pi over 2 and 3 pi over 2. That's because if you look at unit circle, look at here. Cotangent of 90 is cosine over sine. X divided by y, or 0 divided by 1 is 0. And also 3 pi over 2 is 0 divided by negative 1 is 0. So cotangent of x is equal to 0. We're looking for the angles that gives us that, and that angle is basically 90 degrees and our pi over 2 and 3 pi over 2. Okay, question 2. Solve the equation. Again, what we need to do is we're going to, we have cosine on both sides, by the way. We have cosine here, so we bring it to the left side automatically. When we do this, we have negative cosine. You bring it from one side to the other side, the sign changes. Factor them out, and we're going to get this. Now set each factor equal to 0. This equal to 0, and this equal to 0. So when we do this, we get cosine equal to 0, and cosine equal, sine x equal to 3. So this has no solution. That is because the sine at the max could attain only 1. So a sine of x cannot be 2 or 3. But on the left side, cosine of which angles are 0, that's pi over 2 and 3 pi over 2. We looked at it a couple of seconds ago. That is because cosine of pi over 2 is the first value right here. And cosine of 3 pi over 2 is also right here, so they're both 0. All right, let's do the next question. The only thing that probably you're looking at is to the 4. So change it to a quadratic. Rewrite it as cosine square x raised to the second is cosine to the 4. And cosine square x minus 2. So now the reason we want to do it, we want to make it look like a squared plus bx plus c equal to 0. By the way, I have a very interesting video on that, so you could take a look at that. When the polynomial of the coefficient x squared, which is a, is bigger than 1. Okay, so factor it out now. It's really easy factors. Cosine square x plus 2 times cosine square x minus 1 equals 0. So again, same strategy. Set each factor equal to 0. And we're going to get cosine square x plus 2 equals 0. And cosine square x equal to -1. Now solve each one of them. Cosine squared. You want to solve for cosine right here, so take square root of the both side and we get plus minus. So right here we know that that's not a real solution. That's not a real number, so it cannot have a real solution. As simple as that. On the right side we have cosine squared, x equal to 1, so cosine is equal to plus minus 1. One is on the right side, one's on the left side, so guess what's that? That's going to be, so we already said that it's going to be -2 has no real solution. On 0 to pi over 2 plus minus 2 has a solution of 0 and pi. So remember that it's 0. It's going to be right here where 0 degrees is going to be 1, 0, and the other one is going to be -1, 0. Okay, so those are the only angles that we have 0 and pi. And this has no solution. This is not a solution. Okay. And I have it right here. Okay, let's move on to the next question. I give you a minute to try that one. That's an interesting one. Okay, so you could see that we have 2 tan x minus square root of 3 equal to tangent of x. Now what's really happening is that we want to make sure that we solve it. So go ahead. So we are writing our equation. Our next step is to basically subtract. In other words, we subtract minus tan x here and minus tan x right here. And when you do that, these two cancels. So we have 2 tan minus 1 tan is going to give you tan x minus square root of 3. Now bring it to the right side. So you add the square root of 3 and you add the square root of 3. And that gives us tangent of x equal to square root of 3. Now you have to find the solutions. Okay, so look at the angle. So let me draw this. You can see it right here, you're in the circle. So what angles give you a tangent of square root of 3? So you probably know that the answer is going to be pi over 3. Why? Because cosine of pi over 3 is 1/2. And sine is going to be square root of 3 over 2. Okay, so now if you want to find the tangent of pi over 3, tangent is, remember, sine divided by cosine, so that's going to be square root of 3 over 2 divided by 1/2, and that will give us square root of 3. So clearly we know that that is the solution. So I just want to elaborate on this a little bit. So the period of the tangent is pi. Okay, so the period is pi. So so you only need to find the solution on interval 0 pi. Okay, because of what? Because the period is pi. So the only solution on this interval. Okay, let's rewrite that. The only solution on 0 to pi is what? Is pi over 3. Okay, go ahead. What happens if you are going on interval -infinity to +infinity? So I want you to think about that, or the general solution. I'm going to pause here. Okay, so what happens on interval -infinity to +infinity? So the solution on interval -infinity to +infinity, the solutions are found by adding integer multiples of pi. Okay, so multiples of pi. So therefore, the general solution is going to be x equal to pi over 3 plus n pi. That's the general solution. Okay. Okay, very good. I think we're doing cool. And let's move on to the next one. Okay. All right, I have a unit circle for you also there. Let's go ahead, solve it. I pause a second. Pause a moment. Okay, so what we need to do is we have 4 sine square x plus 1 equal 4. So we write our original equation all the time. That's my practice. And then what you're gonna do is subtract 1. Go ahead, subtract 1. See what you get. Okay. Okay, so I get 4 sine square x equal to 3. And then the next step is to solve for sine square. So we bring it to the other side, divided by 4. Sine square is multiplied by 4, so you divide by 4. And then you take a square root of both sides, so you get sine x is equal to plus minus. Remember that anytime you have a square and you want to take a square root on the right side, you have to write the plus minus. Okay, we talked about fundamental theorem of algebra in the class today, and we said that that polynomial of n degree has n complex roots. So we have, if x is to the second, we have 2 solutions. Here also we have 2 solutions, but some of those solutions are according to fundamental theorem of algebra. Some of them are complex, not real, but here we are looking for real solutions. So so let's look at here our interval 0 to 2 pi. Why 0 to 2 pi? Why 0 to 2 pi? Because the period for the sine function is 2 pi. So when sine is, when we have sine of x equal to 3 divided by 2, is only 3 pi over 2 when x is going to be pi over 3 and 2 pi over 3. Let's look at here. Sine of x is sine of x for pi over 3. Pi over 3 is right here. And look at the sine value, it's square root of 3 over 2. And look at the other value that we're looking for. What's the other one that we have? We said that, okay? It's 2 pi over 3. Let's look at 2 pi over 3. And what's the sine? Exactly the same thing. Now you're looking at, once you find that, now look for the negative case. Okay, when do we have negative? Sine is negative in the 3rd and 4th quadrant. So look at here. On the 3rd quadrant, we're going to get 4 pi over 3. Sine is negative square root of 3 over 2. And finally, on the last one, the 4th quadrant, we're going to get 5 pi over 3. Sine is negative square root of 3 over 2. Okay, now, I'm writing a conclusion here. Therefore, the period is 2 pi. Okay, since the period is 2 pi, the solution on negative infinity to positive. In other words, from a negative infinity to positive infinity has a general solution. And that general solution is always going to be the pi over 3 plus 2 in pi. Because 2 pi, remember that? And we have, the other one is going to be 2 pi over 3 plus 2 in pi. So all you have to do is look at these 2 values and add 2 in pi. Okay, because the period is really, the period is 2 pi, so you say 2 in pi because it's going to work, it's going to have infinitely many solutions, uncountable. Okay, I think that's it. That's our solutions for our class handout.